Hi, I'm SynthBoo. Welcome back to another video. This is another technical one. Like my previous one on using the NerdSeq, last time I showed how you could hook up a fader bank to control things within the NerdSeq. And so that's really cool because you can play it more like an instrument. But today I want to go a step further. And I have all of these input devices here. I have a whole rack of them. And we have everything from, these are theremin antennas here. So when you get close to them, they actually detect that and create CV output. Then we have a two-dimensional joystick here. We have a two-dimensional touchpad. We have another touchpad here. Here's a pressure-sensitive touchpad. We have light sensors, and we have this other bar from Dopefer that allows you to play it like a cello, basically. And so there's a lot of devices here that can be used to make a synthesizer more like an instrument. But the problem is the NerdSeq only has 4 input channels. And so that's pretty limiting. But fortunately, there is this module by Expert Sleepers. This is called a CVM-8, and it allows you to add 4 additional CV inputs to the NerdSeq. And it uses I2C communication. And that's great because that's the same thing we use for the fader bank. And I heard it's actually really easy to do. So I figured I'd try it. And I'd let you know exactly how this can be done in case there's problems. And you should always expect some problems. And then we'll be able to do more with the NerdSeq and the whole synthesizer because we'll be able to add more inputs to it. So I'm really excited about this. And I think that other nerdy people who are into the NerdSeq will be as well. First thing we need to do is to configure the Expert Sleeper module and then also the multi-IO module for the NerdSeq. So the multi-IO module for the NerdSeq is required for doing this I2C integration. Fortunately, the Expert Sleepers CVM device is really easy to configure. There is a switch for pull-up resistors. The default is down, and that's good. And there is also a way where it can use this what's called the setup bus to communicate. We're not going to use that, and so we can just keep the jumpers here at their current location. Then we need to set the dip switches, and so the dip switches are explained in the manual. And what they do is they specify the type of configuration you want to have loaded at boot up. And it can be like I2C communication or MIDI communication. I look at the documentation here and I can see that the settings that I want for I2C communication are 1101. And so now I'm going to actually change the dip switches. Okay, so now the dip switches are set to 1101. The next thing is to hook up the I2C wires. Funston, can you hand me that wire? Great, thank you. This is the connector, and it's very difficult to read. You need to know which is the ground one here. And so you can see barely the writing on the top here is that the right-hand pin is ground. So I'm going to hook up brown to that. And now actually plug it in to the rack. And now I need to hook it up to the multi-IO module. And it's a little tricky here, because I have to hook up I2C communication again. I have to make sure I hook it up to the proper wires. And so here you can see that this is for the second port, for port B. If you look real close, I can see that the ground is the one on the right. And so plug a brown wire into that one. And then the jumper cable, just like a previous video when I hooked up the faders, when you use I2C, you have to make sure that the pull-up resistors are proper. Apparently for this device, you need to move this tab here to the second set of pins. There's a lot of cables here, so it makes it a little more difficult, but I got it. Okay, now I should be able to just place this back in here. And I'm going to turn on the rack. Okay, the LEDs indicating that it did boot up. The NerdSeq is booting up. I have another rack here that I can use for inputs. Clock here to talk to this device. And I can see here that not only is my patch cable lighting up, showing that I have a signal going in, but the device, the module by Expert Sleepers, is flashing red, indicating that it's receiving that signal. But I'm not getting any lights here, so these are the I2C lights for receive and transmit, and nothing's happening here. And so that's a bit odd because I'm pretty positive that I've hooked up everything properly. I'm moving a fader here, and so channel A is doing I2C communication properly, but we're not getting anything on channel B here for the multi-IO, and also the device isn't sending anything. So something seems to be wrong. Now, just to be sure, I've flipped these four dip switches back to 0, which means that it should communicate using MIDI. That should work fine because there can't be an I2C problem if it's communicating using MIDI. So this will tell us a bit more. So in here, switch to MIDI, and turn on this rack up here. So we start getting clock to it, and turn on the rack with the NerdSeq and the expander. And you can see that the LEDs flash, meaning that it was booting up, but it is still not trying to even transmit information for either channel. And so it means that it is not working with MIDI, which means that it's just not working. Must not be configured properly. Let's solve that. So the usual thought when something like this happens is that, well, I've done something wrong, because this can be a little bit complicated. Maybe I didn't hook things up right, but I thought I did hook up things correctly. So I started searching around, and I found that several other people have run into a problem with the module, with the Expert Sleepers CVM-8. It turns out that sometimes it's just not configured properly. That's a bit disturbing, but that could happen. Usually the problem resides in the user. But this time I really do get the feeling that there is a problem with the module, and that it doesn't have its factory configuration that it's supposed to have. And I found that out by several forums. So what we need to do is configure it ourselves. And that's kind of a nuisance, because the way you configure this is by hooking up MIDI to it. And then you can run the software from Expert Sleepers, and you can check out the configuration and also make sure that it is configured properly. And so what we have to do is, first of all, hook up MIDI to it. There is no accessible MIDI port here. Well, what I had to do is buy some parts on Amazon, basically a minimal set of parts, so I could create my own MIDI cable that could be connected to this device. I'll show you how I did that. The big question is, how do you connect MIDI to this module? It's got these little headers here. It doesn't have like a regular cable type of connection, and so it makes it a little difficult to do this at home. The most straightforward way to hook up MIDI to the Expert Sleeper module is to get a breakout expander. And these are $50, and you can get ones with MIDI ports, or you can get one that have the TRS inputs. I ordered TRS input one, but it takes a while to come. And so I am impatient and decided to just move ahead and basically create a connection myself. What I did is I actually bought from Amazon some of these MIDI connectors here. And these are real simple devices, and they have nice little connections on the end that you can hook up wires to. And then I also ordered what are called DuPont wires. They already have a mounted little clip on here that will attach to the headers. And then the other side is just a bare wire here, basically. And so you can just take some needle nose pliers and bend it around and put it into the connector. The last part that is needed is a MIDI cable to go from USB on a computer to MIDI. And these are also available on Amazon. This is only about $10 or so. So it's very, very inexpensive. And I got all of this stuff in just 2 days. So what this allows me to do is I can plug in the USB to the computer. This little thing converts it into MIDI. And then I actually already attached the connectors to it. And then I attached the wires, those DuPont wires. I attached those to the connectors and then to the end here. And so now what I need to do is just connect these wires up to the proper place in the headers. I'll probably do it wrong, but with MIDI, it's okay. You can do things backwards, and if communication doesn't work, you just try again. I'll finish attaching the wires. I go to the MIDI connector. And now it is connected. I now have these wires connected to the module, going to the MIDI connectors, going to the MIDI cable, and which in turn goes to my computer. And what I'm going to do is use the web interface. So it has booted up. Now I'm going to try to communicate using MIDI by doing the simplest thing, and it worked. So you'll see here, it's actually sending and receiving MIDI, and then this device also shows that it's getting in and out MIDI. We are talking with MIDI now. That's great. First, I noticed that the firmware version was incorrect. It was version 1.0. And so I looked at the instructions online and how to update to 1.1. And I actually did that update using MIDI. And it's using the web interface that Expert Sleepers provides to talk with the module. Okay, now that we have everything hooked up again, back to the configuration website for the module. And I'm going to request firmware version. And see, I got a message that it's version 1.1, so that's working. Have it query the dip switches. So it says that now it's set to 1101, which is the proper one for the I2C communication. So that's great. If I look at the bottom of this page here, I can see that the saved configurations are all none. So that's the problem. What I'll do is I'll say resynchronize just one more time, just to confirm, and that should actually update these saved configurations. Yeah, they're all none. So now what I'm going to do is actually create a configuration, and the way you do that is you use the configuration wizard here because it's a lot more straightforward. I'm going to set up the 8 I2C controllers, start with number 0 and go up to number 7, and I'll say 0 to 10 volts because the NerdSeq uses 0 to 10 volts for the CV input. Now when I hit go, it's going to take what I've configured here and put it into this window here, continuous generators. And I can see that, yeah, it's configured 8 of these input ports and that they are for 0 to 10 volts, has a proper address here, which is for the NerdSeq, which uses address 49. It's 31 in hex, but 49 in decimal. This all looks good. And so now what I need to do is save this configuration. And nothing is obvious here. So I'm going to type, and already had typed in here, but so I'll say I2C 10 volts. Okay. Your saved configurations, you can see that, okay. Yeah, nothing's saved under this one here. So, you know, I want the dip switches to be 1101. So now I'm going to click on save. And oh, look at that. It actually went here. So it's showing that this configuration now is saved. And now what I'm going to do is load the configuration, which means load it from the memory into the module. So I'll click on load. Okay. And just to make sure everything was working here, okay, I was just doing some communication and I can still get the firmware version and all that fun stuff. Now, one thing I have found out is that the MIDI cable that I got is a little hokey. It was only $10. It seems to get overloaded sometimes. You always have to make sure that you are successfully communicating both directions here, that not only are you sending commands, but that you're receiving commands too. If not, what I needed to do was just unplug the MIDI cable and plug it back in again, and that cycled the power on the cable. And that seemed to work. Now we are fully configured. So we're going to see what's going on with the module. Now that the module is configured, what we need to do is reboot it to make sure that it actually loads in that configuration automatically at startup, and then it actually processes the inputs and sends them via I2C. So we're going to cycle power on the rack, and now the module is actually booting up here and is done doing that, so that's great. What I'm going to do is while the NerdSeq is starting up, I'll go ahead and attach a clock signal, you can see it flashing here, to an input. And look at that. So from here, you can see that it actually is transmitting And it's actually, this is the I2C transmission. So it is sending information through I2C now. So that's great. What we need to do is make sure that the NerdSeq can receive it now. And I can see here on the multi-IO module right here, the LED is flashing red. So it means that the multi-IO module is reading it. So that's great. And now what I need to do is set up the NerdSeq. So I'm going to go to MIDI I2C setup and go down here. It's hidden away, but what I need to do is enable channel B, and so I'm going to adjust that. And so what I set it to is that basically 16N means a 16 channel input device, and it's going to send data to the NerdSeq, and it's going to send it to channel 17 through 32. And it's actually not going to be all the way to 32 because there's only 8 inputs. But it's going to start at 17, basically 1 past 16. Now this is pretty exciting here, but I'm going to set up mapping now. And so I'll say project and mapping setup. And I'll go down here and I'm going to create a new input, and I'm going to get it from the I2C here. So I'll say I2C. That was my large cat that made that noise. So that, and now I need to set it to the proper input channel. And it's a little funny because it's actually number 16, because see, they start with 0. And so for this new device, what I need to do is set it to 16. The great thing is you can actually see that the values here, it's actually corresponding to the clock, and that the value of the input is changing. It's working. But now what I want to do is do something with this information, and I'm just going to try sending it to an output. And so I'll, CV, and set it to pitch, and then I'll set it to like CV3. Let's see, so I've got this device here, I'm plugging it into CV3. Oh, it's still working from before. So let's go to make it, we're gonna have it go to CV2. What I'm gonna do is plug in this little device here. It has an LED in it, it shows output, and I will now set it to CV3, which corresponds to this. And you can see it's flashing here, and it's corresponding exactly to the input. I've successfully hooked up the module and configured it so that it can take CV input, run it through the NerdSeq, and then it can do things with it, like set it to an output or whatever. And so that's it. This does work. The installation is really, really simple, as long as this module was configured correctly at the factory. But it looks like some of the modules, they were simply reset, and so they lost their default configurations. And so I had to go through this whole process of hooking up MIDI and all and getting it to work. But now it does work. Okay, time for final installation. What I'm going to do first is turn off the power to the rack. And the light is flashing because the clock is from a separate rack. But I then will disconnect these MIDI cables because we don't need MIDI anymore. We're just going to be using I2C. And now I can actually place it in here. Okay, now turn back on the power, and the CVM module just did its boot up, and it's already trying to transmit information. It already is transmitting information here, so it is working. Notice that it's using I2C here to transmit this information. Thing to note is that the input is synchronized with the output here, and so it means that the communication, I2C communication, is getting the information to the NerdSeq, and then it's outputting it. And I'm going to change the rate on the clock just so you can see that the input and the output are synchronized. And so as I speed it up, it works just fine. And so we're done. We have 8 more inputs here. We've learned a bit more about modules and configuration and MIDI, and time to take this to the next step. That's it for this video. Talk to you later.